For MODBUS communication using the Teledeogram program, we first use a TCP socket block added to understand whether the communication through Ethernet, GSM, or Wi-Fi will act as master or slave. If it is to act as a master, it is called a TCP client, and if a slave, it is called a TCP server. In the server section, we also define the listening port. If IP filtering is to be done here, the IP address can be written in the text table section and filtering can be done. As seen here, if we want only that IP to connect, we can write it in the text table. And after entering IP address to string table, you must choose this index into TCP socket block so filtering can be done. First, let's define a listening port as a TCP server. For the tests, we will use Ethernet as the media type. After clicking OK, initially, our PLC will act as a server. A remote system will communicate with the PLC over Ethernet. Let's set the slave address differently as 2 instead of 1. We must define slave address 2 for the connected device to read data from the PLC. We took one word register. We sent the current software to the device. Let's start online monitoring. In the online monitoring section, we will read the 4000th MODBUS address with the help of the MODBUS_poll simulator. First, we write the PLC's IP address in the program's connection section. We must select MODBUS TCP IP. We had set the IP to 192.168.10.186. We had also set our port to 502. It gives a timeout error. The reason is that it queries the ID as 1, but we had set the ID to 2. First, we write slave ID 2 and also define the 4000th MODBUS address in the address section. Since we are querying 10 units, we write 10 in the quantity section. Since it's a word variable, we will select the holding register on the function code. First, we double-click to assign the value 456. We read the value 456 at the 4000th address. Similarly, when we send values from the simulator, I read the variable value from the word register block in the PLC project. Thus, I have connected the PLC to my laptop, which is now the master system, through the simulator. Now, we will make the PLC the master. By making the laptop a slave, this time the querying side will be the PLC, and the responding side will be the laptop. Here, we will use the MODBUS_slave program. First, we open the server port as a TCP client through the MODBUS_slave program. The server port is defined as 555. The PLC can open 3 sockets. An edge-triggered input must enter TCP socket blocks enable input because you can open multiple sockets at the same time, allowing you to connect simultaneously. We have reader and writer blocks available for 3 different variable types. Word, float, and long. In this operation, we use reader blocks for reading and writer blocks for writing. For a 0 or 1-bit value, you can take the word reader block and make the variable type inside it a single coil to perform the reading. Let's write an analog expression. We'll use the float reader and the float writer. First, we added a real-time pulse generator to the trig input and tell us how often the Modbus communication will happen. Now, let's take an analog register. In the write operation, the value we connect to the IN input will be written to the variable defined in MFR block. Which address will we read? Let the RTU address be 1. In microdef PLCs, reading is done according to the BADC byte order. We have read the value of the 0th address. We will also write the value at the second address. We have selected the write multiple register function code and clicked OK. Again, we define the BADC byte order. By activating online monitoring with the block properties table, we load the project onto the device in this way. We open port 555 on the computer simulator since we assign the driver port as 555. From the connection section, we open port 555 via Modbus TCP's IP. We define a virtual port. We see that variables are assigned between 0 and 10. Since we will perform a float reading, we select the float type. The addresses 0 to 2 are displayed. Now, let's perform online monitoring. We will also examine the data through the Modbus slave program. First, let's perform the reading operation. We will assign a value to address 0 and read the value 2.8 from Modbus address 6000. Similarly, we will write a value from the PLC. We will send a value to the IN input and write this value to the second address of the slave device. Thus, we can read and write the address values defined within the block. Let's display an increment, for example. This communication speed is also limited in real time by the second defined within the manufacturer. For example, if we set it to 1 per second, we can communicate via the Modbus protocol once per second. In this way, we have implemented two different communication methods. We established the connection with the master-slave logic as server and client. Now, let's talk about the DNS block. The DNS block is used when we connect to a remote system and need to define DNS. This is the section where we define the DNS settings, IP information, and URL, specifying which URL to access. By connecting the output of the DNS block to the input of the TCP socket block's IP and the found section to the enable input, we can use the DNS block in this way. Once again, we specify the IP address of the system to which it will connect as a client. Now let's move on to another method, serial communication. The RTU301 series has one RS485 input and one RS232 input. If we will communicate via RS232, we write 1 for the serial port number. For RS485, we write 0. We define the baud rate. What is the data bit parity? Is it odd or even? What is the stop bit? We define these in the relevant section. This is our block where we define the communication speed and data bit of the devices we will communicate with via the serial port block. Similarly, we use RTU master and RTU slave blocks. Just like TCP master and TCP slave. First of all, let's perform a connection test using the Modbus RTU master block via the serial port block. Similarly, we will proceed with the word reader. We want it to act as a master. It will act as a master via RS485. Let's read the data from an energy analyzer. We have taken two different word readers. The data type of the device we will read is important here. We select the appropriate reader blocks for the type of data we will read and display on the screen. We connected a real-time pulse generator to the trigger input. First, we will read the 0 address of an energy analyzer with a MODBUS RTU ID of 11. I have more than one analyzer with me right now. We will read the 0 address of the analyzer. Let's connect to the device via TCP. When we connect to the device, I enable online monitoring by right-clicking since I did not activate live monitoring. As seen, we have displayed the voltage value here as a word. As I said, I have two different energy analyzers. Different data comes at the edges. We need to divide this incoming word raw value. So that we can carry the comma expression to remote systems by dividing it into an analog operation block in order to see that the voltage value is not 2204 but 220.4 volts. We have the chance to view it. Similarly, let's take the MODBUS RTU slave block. We used the MODBUS RTU master block a while ago. We defined the MODBUS slave address as 10. This time, a remote device will connect to the PLC as a master via RS-485. And let's illustrate this as follows. I took a binary register block. I also took a relay output block. Master device via RS-485. It will send a 1 to the 1005 MODBUS address of the PLC and activate the relay output. To perform this test, let's first upload the project to the device. Open the online monitoring. Here we will also get support from the MODBUS poll program. I'm using the RS-485 converter I have for testing. Then I will make the address 1005. Since binary values are used in the binary register block here, the sign remains, but when I assigned the variable function code as red coil, it displayed the address 1005. When we set set on, it became 1 on the device, and we saw that it triggered the relay control. When we set off, we saw that the relay returned to position 0 again. So, we performed control via RS-485. This could have been an HDMI screen for read-write operations. When HDMI is the master, we saw how PLC is used as a slave. Now, let's talk about the MODBUS slave block. The feature of MODBUS slave is that it forwards all the data from the slave device it connects to via RS-485 to remote systems via TCP/IP. You have the chance to observe all the data directly from the remote system. Thanks to this MODBUS gateway block. How does it work? We connect the block with the serial connection, which is the master side, namely the RTU master block, to the slave side, which is defined as a server from the TCP side, the area where we define the listening port to be connected from the remote system. We load it in this way. So, it was a system where RTU was the master and TCP was the slave. Through the MODBUS gateway block, you have the chance to read all the data. Let's display this as follows. After loading this project, let's establish the connection of the device. I'm connecting to the market via TCP/IP. From port 502. There are energy analyzers at addresses 11 and 12 now. We will display this here. I made the slave ID 11. Let it start from address 0. Since they are word variables, it's the first energy analyzer. All the data is coming. I even increased the quantity to 40. As displayed, there is a value in all the data. This was the device with ID 11. Let's also talk about the MODBUS status. How does it work? For example, in a system where you connect via RS-485 port or as a master, there may be more than one energy analyzer. Now, when we make examples, one of these energy analyzers may have a problem in the 485 connection or may have lost power. We learn whether it is connected or not via the MODBUS status block. Again, let's read data from device with ID 11 and data from device with ID 12. This time, we also connected the We also use the binary register block. We will give the triggering process manually. Normally, you could use a real-time pulse generator. I will provide the contact information with the binary register to see the difference, the trigger information. Again, we connect the master output of MODBUS RTU block's input to the MODBUS status block's master input. And entered MODBUS slave address in the MODBUS status blocks. Let's load the device this project. We will see the status of the analyzers according to the connections of the connections. I'm starting online monitoring. Currently, let's first trigger an analyzer to read its data. The data came, and we saw that the MODBUS status reached a certain position. The other side was at 0 because I didn't send a trigger. I sent the first query again. This time, the status of the other ID device also became 1. Let me send another trigger. The connection is still there now. So, there is no change in the MODBUS status. I'm disconnecting the connection now. I sent another trigger, and this time the status was lowered to 0. So, if there is a connection problem with a device via a 485 line, I received a 0 response in the query I sent. In a situation where one energy analyzer may have a connection problem or may have lost power, you can get the communication connection information from here. Let's talk about the read-write table. We use the read-write table to read multiple data on a MODBUS address that goes sequentially. Again, we connected the master output to the MODBUS read-write block's master input. We wrote the device ID. Start from address 0, read 20 values. We selected the variable type. In this way, we have the chance to transfer to the table. Here, depending on the variable type, we may need to make a table selection again. For example, I selected the word table. We define the word table in the table input. We need to create a table size twice as large for word values. For analog and long, we need to enter 4 times as many values. So, if we are going to read 20 values, we make the table size 40. The trigger input is the area where we determine how long the data will be written. First, let's give a table definition to a line here. Then, in the variable address section, I made the table selection with a starting address of 10,000. I defined the variable type as a word. The automatic number of points became 20. We display the transfer between address 10,000 Let's monitor that the values of the energy analyzer connected to the RS-485 line are written to the table via MODBUS poll by defining a MODBUS TCP slave block to the project. Let's upload the project to the device and start online monitoring. Let's connect to the device via MODBUS poll. In the MODBUS poll read-write definition section, let's enter the slave ID information defined in the MODBUS TCP slave, the starting address of the MODBUS table and the quantity I-20 values appropriate to the table size.